This is John Black, Super Chemist. We're here to talk about some condensers today. Now, I'm not going over everything because I'm basically just answering someone's question. Nikolai asked about condensers. Main two types of condensers, right, are air-cooled condensers and fluid or water-cooled condensers. You don't have to use water. You can use any fluid. What's the difference? Example of a air-cooled condenser. Basically, it's just a tube. Okay, this is a Vigorex column, right, that you would use for distillation. You'd have your pod here, and it would come up through here and condense, and eventually get to the top and go through your water-cooled condenser, right? But this can also be used, instead of it being on the pot, going like that up to the thermometer to still head and then to your water-cooled condenser. It can also be used as a condenser. In other words, your pot would be here, it would come up and go through here and turn into a liquid and go into your, your accepting flask, or receiving flask. But you notice they put these little barbs in here. Basically, when the glass was hot, they poked it with something, right? Poked it with this and poked it with that, and they poked the glass so it went into the middle of the condenser so it can touch more of the fluid that's being evaporated. You know what I mean? Now they have some that are teardrops, some they don't even do that. It's just an empty tube. You know what I mean? With no tears in there, no glass pushed into the middle. What I suggest, if you want an air-cooled condenser, get a Vigorex column like this. That way you can also use it as a Vigorex column on your distillation. You know what I mean? Going straight up and down instead of like a condenser. If you got the choice between an air-cooled condenser and a water-cooled condenser, never buy the air-cooled. Water-cooled is always best, because if you really want to use a water-cooled condenser as an air-cooled condenser, you can. You know what I mean? Just don't put cold water in it. You know what I mean? Put room temperature water through it, that's all. And it's the same as an air-cooled condenser, you know what I mean? So I've never used this as an air-cooled condenser. I always use it as a Vigorex column. I've never, even when I distill sulfuric acid, I use a water-cooled condenser. Do I put cold water in it? No, you will break the condenser. But I put room temperature water in it, you know what I mean? And works just as good as any better really than any air-cooled condenser. Now, the water-cooled condensers, I'm not going over every example. I mean, there's cold fingers, there's hundreds of different types of water-cooled condenser. Here's one example, though. I don't know if you can see it. See how there's like little bulbs in there? That is a Allen condenser. Okay, see the bulbs? That's how you know it's Allen, because it has those little bulbs in it. Now this is called a Graham condenser. You can see it has a spiral, right? And that spiral is where the product goes into the spiral. The water goes around, you know, the jacket around the spiral, right? And then there's also a Dimroth, which is shaped exactly the same way as this, but it's in reverse, right? The water goes through the spiral instead of the product, and the product goes through the jacket, you know, the outer part of this condenser. Okay, which one's better? In my opinion, the Graham is. Why? Why is this the best? I think because when your product comes up, it has to go through that spiral, right? And since it wants to go up, and you can see the spiral is almost horizontal, right? It's like a slant. It's like a slope going upwards, but you can see they're horizontal tubes. The tube is actually horizontal, so it is forced when it comes up. Every molecule must touch that the outside glass of that spiral, and the outside of that glass has water, right? The jacket's all filled with cold water. So that's why I say this is the best. If it was the other way around, and you had the product coming through here, look, it can come up around the side. It can go up the middle, right? The middle, there's nothing in the middle of that spiral, and never touch the cold water that's in the spiral. That's why a Dimroth isn't as good, in my opinion. I didn't mention these three, right? The Allen, the Dimroth, and the Graham. These are great condensers, but they're more for refluxing, okay? And what happens is, see these bulbs? Each one of these bulbs will condense liquid in it, and then will get stuck in it. So you'll have a little bit of liquid stuck instead of it all rolling down into your receiving flask. If you have it straight up and down, it's no problem if you're just refluxing. But if you're distilling, you're always going to have your product getting stuck in there. I hate that. This, however, I love this. Again, though, if you're distilling, you have to have the thing up vertical like this. You can't have it like a regular distillation apparatus. You have to have it come over and go like this and have gravity get your product to go through. Otherwise, it just gets stuck. If you put it like this, like a regular distillation, it comes up, right? Comes up there and goes through the condenser. It's going to get stuck. You cannot get through it. It's going to turn into liquid before it gets to the end. And you just have a whole bunch of liquid puddles in each one of these little coils. So this is terrible for distillation, right? But for reflux, when you have it straight up and down and you're using gravity, you know that even though these aren't totally horizontal, they're slanted a little bit so that this product can slide back down, right? So if you have it straight up and down, this is the best thing you can get for a reflux condenser. The best, okay? When you're refluxing your condenser straight up and down, it's vertical, right? This is the best. Now, if you're doing a distillation where you have your like this, you know, at a kind of an angle, but it's almost horizontal, no, these suck. The best thing to get is this. Now you can see it's just a tube within a tube. I don't know if you can see that or not. See how there's a tube inside there? Your product goes through the tube in the inner tube, and the outer tube, the jacket, is all filled up with cold water. So it's that little tube is surrounded by freezing cold water, and it condenses your product out. This is called a Liebig condenser. Okay, sometimes they call it a West condenser. Actually, a West condenser is almost the same thing, but the inner tube is a lot smaller. I don't really see a lot of West condensers out there. Liebig is the best condenser, all right, for distillations. So if you only can afford one condenser, get a Liebig condenser. Okay, you won't regret it. If you can afford two, get a Liebig and a Graham condenser. One for refluxing, the Graham, and one for distillation. The other thing I suggest is don't buy big condensers. I have a 600 milliliter condenser upstairs. It's twice as big as this one. It broke. Now what? I lost 600 milliliters of condenser. If I would have bought two 300 milliliter condensers and then one broke, I still have a 300 milliliter condenser, right? So that's a no-brainer. Always buy, you know, what I suggest is a 300 milliliter condenser that's Liebig and a 300 milliliter that's a Graham condenser. You can always put them together. Look, you can always put them together, right? And then your water comes in right down here. And then here, where it comes out, you just have it come out and go back right into the next condenser, right? And then it comes out the top. That way it goes through this one and all the way through this one. Now you have a 600 milliliter condenser. And if one breaks, you still have a 300 milliliter condenser left, right? Now Nikolai asked something about, he said R1300 and R111. I have no idea what that means. I've never rated a condenser by R's. I don't know what that R stands for. The only R that I know of, the only R factor I know of is in thermodynamics, and it deals with heat being conducted through materials. Usually they use it in houses. Like an R value of 13 is the standard R value of the insulation that people put in their walls. That white fiberglass insulation that they use in the United States. Well, the standard R factor is R13. And what that means is that it'll insulate, you know what I mean, down to, it's a resistance, R for resistance. It shows how much it will resist the flow of heat from one side of the wall to the other side of the wall. The higher the R factor, the more you're insulated, right? But I have no clue what, I doubt very much that has the same meaning as what you, Nikolai, are saying. You know, I've never heard that put towards a condenser. Condensers are rated by one thing and one thing only in my mind, and that's by length. Okay, you can have, this is probably like 100 millimeter. They're usually rated in millimeters. How, that's how long they are. An average one is 300 milliliters that I showed you. A big one would be like 600 milliliters. Trying to get bigger than that, I doubt you can without buying pieces and putting them together. Okay, prices for condensers are about $10 for every 100 milliliters you get, right? So if you have a 200 milliliter condenser, that's like 20 bucks, 25 bucks maybe. If you have a 600 milliliter condenser, that's like 65 bucks. You have a 100 milliliter one, that's like 10, 15 bucks. You know what I'm saying? So every 100 milliliters of length you get, you're going to pay another 10 bucks for it. You know what I mean? Some people like me, we don't have access to credit cards or this and that. We have to buy what we have to buy. But if you can get on eBay or get someone to get you something on eBay, you can definitely get them for those prices. Don't pay $120 for one condenser. You can get a whole distillation apparatus, including the condenser, for $120. The reason why you got a water-cooled and an air-cooled, the air-cooled is for really high temperature stuff. Let's say I'm boiling something like sulfuric acid, 337 Celsius. I'm not going to want a water-cooled condenser because it doesn't take much to bring that 337 C down to 336 C, basically, to get it back into the liquid form. It doesn't take a lot of energy. So you wouldn't use a water, if you did use a water-cooled condenser like I do, you would just put, room temperature water in it. That's all. You know what I mean? You don't put no ice-cold water in it, and it does a better job than this as a condenser. As a Vigorex column, these are great. Air-cooled condensers, great. But as an actual condenser, I don't think they're worth it, unless you're going to use it as a Vigorex column also. So anyways, the whole reason I made this video was for Nikolai, basically. So to answer your question, I don't know what the R factors are that you're talking about. I would buy a water-cooled condenser over an air-cooled condenser any day of the week, and I would never pay $120 for it. If you have the money to do it, I would get a 300 milliliter condenser that is a gram condenser, right? I would get a 300 milliliter condenser that was a Liebig condenser. That way you can combine them together and have a total of 600 milliliters. You have the gram for refluxing. You have the Liebig for distillations. And then I would get one Vigorex column, which is technically it is an air-cooled condenser, but I would use it as a Vigorex column in fractional distillation. I wouldn't really use it as an air-cooled condenser, but you could if you wanted to. Old stuff. You just get a fan, but some people put a fan on it, and basically just the air blows over, just like you blow your food that's too hot, right? So anyways, there are more. There's a cooled finger, and there's other different types of Vigorex columns and condensers. I'm not going into all of them because these are the main ones. And basically, I just wanted to answer Nikolai's question. 200 milliliters is okay. 400 milliliters is okay. 300 is about perfect. Okay, here's my two prongs for on here, whatever you call these things. I forget. How do I know which one is water in and which one is water out? Well, the water in always goes on the bottom. Okay, and the way I always remember it is I have a pump. Why would I pump it from the top down? I would pump it from the bottom up, right? That's just common sense, even though it really doesn't matter. But you always go on the bottom. Now, if you have it like this, even though there's not a bottom on the top, you can see this side is lower than this side, right? If you have it as a distillation, you would put it in here, out here. So anyways, I hope somebody out. And you all have a great day, and always remember, science is great.